Hi friends, welcome to my channel. Let's have a look at problem 841, keys and rooms. In this video, we are going to share a solution based on the graph concept called connected component. So in this problem, the graph is actually a directed graph. So we are going to write a hyperfunction to check if all the rooms are lying in the same connected component. So first, let's read through the problem statement to digest the requirements, and then we do the analysis, and finally we share the code. So first, the problem statement. There are n rooms labeled from 0 to n-1, and all the rooms are locked except for room 0. Our goal is to visit all the rooms. However, we cannot enter a locked room without having its keys. So when we visit a room, we may find a set of distinct keys in it. So each key has a number on it, so denoting which room it unlocks. And we can take all of them with us to unlock the other rooms. So given an array called rooms, where rooms I is the set of keys that we can obtain if we visited room I. Return true if we can visit all the rooms, or false otherwise. So here are two examples. So in example 1, the return is true, so as explained in the explanation part. So in the example 2, so the return is false. So before we do the analysis, let's also look at the constraints. First, this n can be retrieved from the length of the rooms list. Secondly, n is bounded below by 2 and bounded above by 1000. So the others are some consistency assumptions. So meanwhile, all the values of rooms I are unique. So with that said, we are ready to do the coding. Actually, for this problem, in this video, we are going to cast this problem into a graph problem. So with that said, we are going to do the coding directly, and in between, we explain the ideas. So first, I'm going to prepare for the graph, or make a graph representation. So here, let me going to use this collections default dict. So I'm going to use a set as the container, or default, use the empty set as a default value. So with that said, let's do the following. So we iterate over the rooms. So for room and keys in enumerate rooms. And then what we are going to do is that graph room is going to union with this set consisting of the keys. So let's do this set of keys. So here I'm doing a type conversion. So with that said, we finished building the graph. So next, I'm going to write a function called get connected component. Get connected component or components. So here, let's do this. I'm going to use get connected get component. Let's see, component. So I'm going to have a source, right? So in our problem here, the source will be room 0, right? As here. So this is the entry point. So for this, this is very routine. So we can use traversal. We can use breadth first search, or we can use depth first search. Both are okay. So here I'm going to use a set to hold the nodes in the connected component. And then here I'm going to use depth first search, but depends on how we use the this list. So it can be a stack, it can be a queue corresponding to depth first search and breadth first search respectively. And then I'm going to write a iterative format. So while stack, so this is standard, right? So we're going to have the node with the stack pop, and then we're going to add this node to our result. This result is a set, so it represents the connected component. And then for key in graph node, so then if key not in result, then we're going to put it in the stack. So to two p's, right? So append key. And then this is the standard traversal procedure. Then we just need to return the result. So this is the second step. So this is a hyperfunction. So next we are going to write the problem logic. So for this, so we are going to return. So first I'm going to get component, right? This is our entry point. This will be room 0. And then we are going to check if the length of the connected component containing 0 or represented by 0 equals the number of rooms, that is n, right? Let's also do this, rooms. So this way, we finished one format of solution. So we can do a check. It passes one example. Now let's look at another test for all the cases. It passes all the cases. So here, before we end this video, let's do two comments. First, here, for getting the connected components, we can use breadth first search, or we can use depth first search. Here, because we are using this list as a stack, we are using depth first search. If you pop 0, so it corresponds to breadth first search. Let's do a check. Yeah, but you need to change the name to be queue. That's much better, right? Let me restore it as using as a stack. So this is one comment. Another comment is that, so for finding connected components, so typically there are two ways. One is to using traversal, and the other way is to using union find or disjoint set union method. So here, because the graph is a direct graph, so we didn't use union find method. The union find method is very effective when the graph is bidirectional or undirected. So with that said, I guess that's about it for today's daily challenge problem. You're welcome to check out other videos on graphs in my playlist or in our channel. So with that said, that's it. Thank you.